Hello everyone, welcome to my presentation. My name is Emre and I am from Izmir, Turkey. I am at STFC Harvey Center in United Kingdom. I will introduce you my topic hybrid Monte Carlo and deep learning methods for matrix computation on advanced architectures. Have you ever realized the waiting time for the machines decreasing day by day in our daily life? Do you remember how long you were waiting for old devices to open? How do we express the real-world problems to the machines? For example, this is how we see images. However, the machine sees image as numbers in a matrix. Before explaining the project, let's get back to past.
Previously on Summer of HPC.
In 2017, Anton Lebedev successfully implemented an accelerated Markov chain Monte Carlo method using cold-blooded theoretical analysis and simple experiments. Though using the method yields a bad inverse matrix as can be seen in the left figure, it's good enough as preconditioner. However, with a clever recovery produce, inverse of the matrix can be computed better with a huge cost. He also stated that this process can be improved by future SOHPC participants. Let's continue. The aim of the project is improving the inverse of the matrix from Monte Carlo Markov chain inversion method. To achieve this, a method used based on the paper named stochastic gradient descent for missing data. Besides the fancy math and the calculation, let's try to simply understand the method. Firstly, the stochastic gradient descent algorithm minimizes an objective function in an iterative process. Since we want to have better matrix inverse estimation, our objective function becomes a least square. But that's not enough. A uniform randomly selected row will be used each iteration to update the inverse. Each iteration, the error will be minimized with gradient operator. While updating the matrix, and new information added according to the learning rate. If it is too much, it will forget everything. Or if it is too small, the learning process will be slow. Don't worry, Black Box will handle the computation to make things more visual. Let's start the process. As the iteration increases, error is minimized. The row for iteration was selected uniform random. But what if probability to select the row was according to the norm of the row? The results are slightly better. Another bonus is mini-batching with parallelization by splitting rows into the process. Let's start the simulation by assuming having 4 cores.